We are going to get started. Good afternoon, everyone. Thanks for joining us for this pre-college summer experience talk with Dr. Melissa Lott, where she's going to share information about a particular topic that she is going to be overseeing in Iceland this summer, in partnership with a program that we have with Putney Student Travel and the Columbia Climate School. These are summer traveling programs that we are doing for the first time, and we're very excited about offering this opportunity, particularly to Iceland. And the theme of the trip is carbon capture and carbon capture technology. And the goal behind these trips is to really offer a tailored experience for students who are interested in this particular theme and topic, and to study it from being immersed in the location and using place-based education to really enhance your educational experiences. So the trip to Iceland will be happening July 20th to August 1st this summer. And we have space for 16 students as part of the trip. And a more detailed itinerary can be found on the website. And I'm going to share the link to the website in the chat box in just a moment. If you do have questions that come up during the session today, please make sure to use the Q&A box, and we'll be sure to address those questions. Some of the big themes that are going to be explored this summer include decarbonization and pathways. So what does it really mean to decarbonize? What are the policies that are in place? Another topic includes pioneering technologies and policies. So what is Iceland doing that is unique in response to our changing climate? Renewable energy technologies and scale is another topic that will be addressed. Carbon capture and how it actually really works and the science behind it. And then what happens and the possibilities that you can have when you combine science and engineering and opportunities, and what this means for addressing climate change challenges, and coming up with solutions and actions that really can make an impact at scale. So those are just some of the themes that will be addressed this summer. I'll turn it over to Dr. Lott here, and she'll introduce herself, as well as give you an overview and just kind of what is happening in the space, the thinking, and we will be happy to address questions afterwards. And I will put the link to the summer traveling program in the chat box. Melissa, if you want to go ahead.
Yeah, thanks, Cassie, and thanks for everyone for joining us. So again, just put your questions into the Q&A box as they pop up. I'm hoping everyone can see this on the screen. Cassie, let me know if you cannot.
Yeah, so we see it. It's a bit of sorry, it's very narrow on the screen.
Interesting. Okay, let me switch to my other monitor, and it should make it a lot bigger. 1 second. Luckily, this one's an easy fix. So just dragging it over. Okay, and let's try sharing again. Is that better? Is that much larger?
Yes,
I hope.
Much larger, much better. Thank you.
Wonderful, wonderful. Thank you for letting me know. I hate to have everyone squinting for the next little bit here. So again, just let me know if you have any questions as we go along. Part of the great thing about these summer immersion type courses with a small group, when you're talking about 16 students and different instructors, that we can really have a discussion. So what I wanted to talk through is, when I think about carbon capture, and when I think about renewables, and when I think about all of these words that we hear a lot about when we talk about mitigating or fighting climate change, to me, the tech is really cool. I'm an engineer. I love to know how it works. I want to know, how do we actually get the carbon out of the air, and where does it go, and how do we turn it into a rock or store it underground? But really, the whole purpose of it is about reducing emissions. It's about mitigating climate change. It's about fighting climate change so that we have a healthier future and a more sustainable future. So thinking through that, I just want to talk through a couple of different things. And you might know pieces of this, but we'll step through it. So when we think about, why are we even talking about carbon capture? Why are we even talking about renewables? Why are we talking about energy? It really comes down to this picture here. At the end of the day, when we look at where greenhouse gas emissions come from, basically 3/4 of it comes from what we call energy. And energy includes a whole host of things. So it includes things that are obvious, like emissions from power plants, from the things that produce electricity that keep the lights on in our homes. It also includes things like industry, when we make steel and cement and all the types of things that actually build the stuff that we use in our everyday lives, whether it's our home or whether it's our car, or just the things that we use, a toaster oven, a light bulb, our computer. So what actually goes into that? So coming through industry. This also involves chemicals, which is stuff that is found all around us in every dye that we see, in most of the things we consume in our daily lives. This also includes transportation, so cars and trucks and planes and ships and all the things that move us around, that provide mobility, that allow us to get from A to B. And then energy use in buildings. So this is residential buildings, these are our homes, so the energy that we use and the emissions that are produced when we cook and when we heat our water and heat the air that's around us or cool it in the summers. And then the rest of it are a whole host of things that are a bit smaller, but talking about energy use in agriculture and fishing, and then stuff that we call like fugitive emissions that are associated with energy, which just means that when we're getting energy from, the point and the form that it comes in to the point and the form that we want to use it in, so turning whether it's coal into electricity that keeps the lights on or what have you, what happens in that process and what emissions are produced. So if we want to mitigate or solve or fight, whatever word you like, climate change, we really need to think about energy. And in this, renewables and negative emissions technologies, so things that pull emissions out of a process or out of the air, are really, really important to actually getting to what we zero. So that's the target that we have. We want to hit by about mid-century if we want to actually reduce the worst effects of climate change on our health and on our environment. So today, we've done a lot of scenarios. So we've run a bunch of models, done a ton of math, looked at all the science, looked at all the technologies that are out there, and we've said, what's actually the cheapest, the most practically achievable, way to get us all the way to net zero, to mitigate climate change. And what we find time and time again is that electricity, so the electrons that keep the lights on today, in the future do a lot more than keep the lights on, do a lot more than even create heat. If you have an electric, heater or heat pump, air conditioner, these types of things, they actually end up being, electricity ends up being the backbone of how we get to an affordable zero carbon future. So we produce electricity in a lot of different ways. Today we use a lot of coal around the world. We use a ton of natural gas around the world. Increasingly we use natural gas in the United States in particular, as we've discovered processes called fracking and other things. We also use nuclear power and then a bunch of renewables. So we've seen a ton of wind power deploy over the last decade because it's gotten so much cheaper than it used to be. We also see solar power being used. And hydroelectric power, really big dams, and then little turbines that we put into rivers so that it actually spins when the water in the river is running over it. And then we still use a good amount of biomass. And often when we talk about biomass, so trees, grasses, dung, we think about, developing economies, low-income economies, places in the world where they don't have access to electricity, they don't have big power plants and huge transmission grids, so the wires that move the electricity around. But actually, we use biomass, we use wood around the world still today. So, historically, when we've looked at how we use energy, we keep adding fuels on top. So we used wood, we discovered coal, we discovered oil, we keep adding things. But as we go to net zero and mitigate climate change, we actually need to start subtracting things, moving away from the stuff that's producing the emissions that are making, the world sick effectively. So that means shifting away from some technologies and using other ones a heck of a lot more. And so what I thought I'd do for today, let me just go to this next slide, is talk us through how we produce electricity specifically today, and talk about renewables and carbon capture, which is the topic that we're really going to drill down on in Iceland this summer for a number of reasons that I'll talk about. But think about how they actually get us what we want. Like I care about the technology because I'm an engineer. I like tech. I think it's cool to look at, but I really care about it in terms of how it supports me having the things that I want in my day-to-day life. So this is just breaking down right here how we get electricity today. So this is around the world. So this does vary depending on what country you're in, and in the US, what state you're in, and even what region you're in within that. But we get a lot of it again from coal. That's that gray bar along the bottom. Natural gas is next, and natural gas has increased in terms of use over time. And this is because that technology has actually, or that fuel rather, has gotten a lot cheaper than it used to be as we figured out how to get it out of the ground a lot more cheaply. We also do use oil to produce some of our electricity. This is particularly true in island nations, so the small islands around the world. Not, however, in Iceland, which is really interesting, we'll get to in a minute. But islands where they don't have a ton of natural resources or just land space to produce the electricity that they need or want. And so they burn oil. It's a really energy dense fuel. There's a lot of energy in every, barrel of oil, so they burn it. And then we use nuclear power above that, and that produces a substantial amount of our zero carbon electricity. And as we go out from nuclear, these are our zero carbon electricity uses that we use today. So there's nuclear, hydropower, so water, and then wind, sun, and then bioenergy, which we talked about. Some of which can be considered sustainable and some of which is not. And so this is how we produce electricity today. So the question is, how do we actually produce electricity in the future? And what is the role within that of renewables like wind and solar and hydro and geothermal, which is huge in Iceland? Really, really impressive. But also, what is the role of carbon capture? What is the role of all these technologies that pull carbon out of the air to give us what we call the net in net zero? So I like to think of it in terms of soccer, not because I'm a great soccer player, but because I love the game and I like playing it. And I think it really illustrates what we're trying to accomplish and how these different technologies play together. So when we look at the different technologies that we need to bring together to actually make an all-star team. So by all-star, I mean electricity that's reliable, that's accessible to lots and lots of people, all people around the world, and also affordable so that people can pay their bills. What do we need? So we want some strikers. So we want our variable renewables. This is our wind and our sun. So these are things that when they're around, they are so cheap. I mean, they are ridiculously cheap. The costs of these technologies have really fallen, but they're not around 24/7, 365. Like there's times when, wind and sun just aren't blowing. And it's not just a few hours that the sun isn't shining and the wind isn't blowing. It actually can be for weeks at a time in different parts of the world. There's terms in many languages that basically mean when all of the different variable renewables don't work at the same time and what happens there. And there's a term for it in lots of different languages because this happens around the world. So you can think of Southern California as this like sunny place that also has like these, elevation changes and great wind. And the reality is they have multiple times a year where the wind and the sun are both pretty poor. And so you need to fill it with other things. But man, when they can run with the ball, you want them to have it. You want to feed that ball to them and have them run it straight at goal because you're going to score a lot of the time. So what you do is you complement those variable renewables with midfielders. So when you think about midfielders, I think about this as energy storage, which is also something that we'll be able to study a bit in Iceland, which is saying how do we actually store the energy from our strikers, from our wind and solar, so that when the sun goes down and the wind calms down, we actually still have energy to fill some gaps and to keep the lights on. So these types of things are these big batteries, and also things like hydrogen, which is something else that we can see in Iceland. So these are the things that take electricity and put them away for a bit. It's like a savings account and save them for you for another time of year, another time of day, just another piece of your puzzle is filled with these types of technologies. Now, the third part of our team are defenders. So strikers are great, midfielders are great, but you need your defenders if you want to keep the ball from going in the goal. So these are our 24/7, 365 power plants, and this is where it really excels. So these are things like geothermal and hydro and nuclear. So technologies that just produce electricity whenever we want it and keep the lights on. This is also power plants that still use fossil fuels because we can use fossil fuels in a zero carbon world, in a net zero world, but that have technologies attached to them that actually pull the carbon either out of the smokestack or out of the air to make sure that they're not producing more greenhouse gases that go and change the climate, but they're actually taking that, turning it into a rock or storing it underground as a gas or turning it into some other product we want to use. So storing it in concrete, putting it somewhere else. And this brings me to the last point. Those negative emission technologies are actually what I consider the goalie on our team. So you want to reduce emissions in a climate friendly world, in a net zero world, by having wind and solar do a heck of a lot of lifting, by having geothermal and other renewables do a lot of lifting, but you still might be left with other emissions that are left over. And this isn't just true in power, this is true with a lot of the different things that we do in our daily lives. So there may be a case where you can't produce, let's say, cement in a way that has no emissions. So what do? You literally suck those emissions out of the air so that they don't go and change the climate. They get stored safely underground or in a rock or some other, some other way you store them and you put them away. So when you think about different carbon removal technologies, some of these are tech, and this is actually a picture from a carbon capture facility that is in Iceland. But you can also think of it in terms of other types of technologies, and other types of processes. So there are carbon dioxide removal processes, there's carbon cycles that we can figure out. How do we actually grow trees to store carbon? How do we actually create it so that our entire ecosystem that we work in is actually more in balance and is absorbing more carbon dioxide and other greenhouse gases than we are putting out, so that we can actually literally be pulling these emissions out of the air? So I want to talk about Iceland in particular. So Iceland is one of very few countries in this world. I'd say New Zealand is another. They give us a really fascinating snapshot of what the future could look like for all of us and will someday look like for all of us. And I say that because when you look at how Iceland gets its energy, and so this picture here isn't just electricity, which is what I've been talking about, it's actually energy more broadly. Iceland shows us how we can have an entire system that is actually a net zero system. So they get a ton of their electricity from geothermal and hydropower. So about 70%, I think it is, of their electricity comes from hydro, a bunch from geothermal. Geothermal also produces heat for a lot of their industry. So they've got a big aluminum production and other things, and they use geothermal for that. And they still use a bit of coal and a bit of oil coming in transportation amongst other places. So for cars, because they're not electrified yet. But when we look at Iceland and we look at the use of geothermal in particular, so we think about what is it actually doing? So in Iceland, we can study the use of geothermal, not just for electricity generation. So 40% of geothermal power is actually used for electricity generation, but also direct use for heating buildings. So we talk a lot in climate worlds about electrifying buildings, about taking everything so that everything we use is based on electricity. But actually, Iceland is an interesting case study showing us how we can use heat from the earth directly to give us the things we need, like heating in buildings during the winter. They also use it to keep swimming pools warm, to run greenhouses, to do sustainable food production, for fish farming, which is really fun and interesting to look into, for industry, like I mentioned, and for melting snow. So there's just a whole host of things that we can think about when it comes to geothermal in this country, and something that we can think about is Iceland actually being an amazing case study for the world. Now, Iceland also, and I apologize, the picture didn't pop up, but Iceland is also moving forward when it comes to all of these carbon capture technologies. And so we can actually see carbon capture in action, showing us how do we pull this energy or these emissions from the air? How do we pull these emissions from smokestacks and actually prevent them from going into the air and affecting our climate in the short term? So a couple different things that I'll just flag real quick is that, if you want to learn more about this, in a minute I'll show you, we have a podcast that actually talks about all these topics in detail. But the second thing I'll highlight is that I know when I was learning about energy, I actually went to New Zealand and studied there to learn how do we use this stuff in a practical sense. So Iceland is one of those other countries that I considered, and I'm so excited to teach there and to teach a bunch of y'all there, because it was one of those other places where it really is a case study where we're getting a glimpse into the future about how all these technologies that, like here in the US, we're using, but we're not using as much. And Iceland is showing us how do we actually move to an entirely net zero future, and they are decades ahead of us. And that's really just an exciting place to be in terms of study. So if you want to learn more and go really into the nitty gritty of all the stuff I was just talking through, we do have this podcast. It's free, so please feel free to check it out. And with that, Cassie, that is my brief overview. I don't know if anyone has questions or wants to talk through any of that. I know it was a lot of information pretty quick.
Oh, good, thank you. I will open it up to the our viewers here, and I will just get things started. I'll also share the link to the Big Switch in the chat box for our viewers in just a moment. In terms of, Melissa, you touched on this a little bit, but these immersive opportunities for students to join these to join small sort of traveling sessions in specific locations tailored to a specific themes. You said you really enjoy teaching them, but what do you think are some of the biggest benefits to students, and is it also valuable for you as a teacher to be involved in these experiences? Because often we find that we learn just as much from high school students who participate in these opportunities as much as they might learn from us.
Absolutely. 100%. It's part of what I love about teaching, period, is because I'm learning every time, and that's exciting to me. I'm an educator and I'm an academic. Like, I love that I get to learn through my whole life, and that's an amazing thing. Different things that I'll say is that often as we go into college, and in my case, you go and get a PhD and you specialize and you go down this one specific path. And it's really easy to focus on that piece of the puzzle. And I'll say that often when it comes, especially to working with high school students, y'all are amazing at helping us think about the bigger picture and all the other pieces of the puzzle that go into it. So how does this connect to my life? How does this connect to work I might do? How can I participate? Like, those types of questions they're exciting and interesting and tough. Like, they don't have one answer. It's not 2 + 2 = 4. It's way more complex than that. So I'll say I studied engineering. I also have a degree in policy. So this idea of, if I want to be a part of this, how do I blend technical things and policy things, or economics and finance, business, all of these different topics? How do we all work together on that? The other thing I'll say, like, being in a place like Iceland and in Reykjavik, where you've got like the district heating networks that are actually moving heat around, like I talked about, to directly heat buildings, and also seeing it generate electricity, and then combining that with the carbon capture technologies that can help us pull this stuff that's making us sick out of the air. Like, to be able to see it and to understand the scale of it, that's just an amazing reminder. It doesn't matter how many power plants I see, and I've seen a lot. How many power plants it's one thing I really enjoy. But it doesn't matter how many I
I love
see,
it.
they're massive and interesting. And y'all will ask questions that I wouldn't have even thought of, because I've been looking at them a bit too long. And so you'll ask about a question, a lot of which I'll have answers to, other ones I won't. And so we'll find the answer together, because some things are not, something I've studied before, and it's a question that we'll ask local folks who are working on it every day, ask the engineers, what breaks in this power plant? Like, what doesn't work? It looks pretty self-contained and easy, but let's ask them.
Right. No, I think that's a fantastic perspective, and I know that we certainly always get challenged with questions that we have not even thought of, and that's what's really exciting about these opportunities. So we have a question from Zoe about if Iceland has been doing this for so long, why is it that the US is only getting into it now? Very good question.
That's a great question. So there's a couple different things when we talk about, like, why is Iceland where it is? Why is New Zealand where it is? So Iceland gets 70% of its power from hydro and 30% from geothermal. There's actually a tiny little bit of other stuff, but we'll just go with big numbers. Other countries like New Zealand, same thing, 70% of its electricity comes from hydro. Why? Because they have those resources. So in the US, we are, lucky that we have tons of natural resources, including a heck of a lot of oil and gas, which are actually produced very, very often the same wells. And so when you think about, we went for the cheap stuff, the easy stuff, what was available to us in the US, different than what's been available to folks in Iceland. So if you're looking about using fossil fuels, a big determinant in how expensive it is to do that, so to how to use coal, natural gas, and oil, a big determinant is, like, can I produce it here cheaply? Or do I have to get it from somewhere else and move it here, in which case it gets a lot more expensive? So natural gas in the US might cost a few dollars per unit. In Japan, where I used to live, costs 15, maybe 20. Used to be higher. In Europe right now, it's even higher than that. So it depends on where you are, what natural resources you have. Some places are very windy. Some places have a lot of water. Other places don't. You're in the middle of the desert, you don't have that. Iceland's fascinating because they not only have a bunch of water, they have a ton of geothermal. And we don't have that everywhere in the world, not easily tapped into at least. And so they've been able to really start developing it. Now, there's other things in their history that we can really get into during the summer to talk about sustainability and self-sustainability. So they're focused on actually being able to be completely self-sustained if they need to be. So being able to produce food in Iceland. Even though right now they import a lot of it, they have the ability to increase food production on the island. How they want to not have to import fuels, what the drivers are that not just cost, but also policy, cultural, all those contributions, because all those things matter in terms of the decisions we make. I hope that answers your question, Zoe, but if not, just like throw another question in the Q&A and I'm happy to take it.
Great, thanks. And I think you touched on, this is nice sort of segue into a point that I forgot to make at the beginning of the session, which was that we actually will have an additional faculty member from Columbia joining the trip as well. And so how the Iceland trip will work really is there's a certain set of days where all the students are together, and then we have Columbia faculty joining for parts of that trip. And what's really interesting about Iceland, I mean, there's so many interesting things about Iceland, but one of the interesting things is that it's capable of all of many of the technologies that they are scaling that we don't necessarily see in the US. A lot of that is attributed to its geology. And we're actually going to have another faculty member, Art Lerner Lamb, who is a seismologist and still is a seismologist, and he's transitioned into some other work, but that's where he started in Iceland for seismologists or for volcanologists, for glaciologists. It's all fascinating to them because of just what is naturally there. And so you're going to be able to really be introduced to a lot of different content areas. And there's also plenty of time for fun as well. So in addition to the content through Columbia's faculty members, we are, along with Putney, are going to be working very hard to make sure that you also get to have fun. So you'll be kayaking, you'll be scouting for puffins and whales and seals. There's a visit to a national park where you'll straddle tectonic plates. You'll definitely get to see a power plant, a geothermal power plant as well. And you're really learning directly from individuals who are there, but also experts from Columbia who are really immersed in these in the content area. And I should say that we also have scholarships available for all of the traveling programs. We have other programs available to travel to California, where the theme is disaster preparedness, New York City, where the theme is sustainable investment and entrepreneurship, and to Alaska, where the theme is climate storytelling and working with indigenous communities and advocacy. Iceland is our only international trip that we're offering this summer with Putney, so we're really excited about that. And so the scholarships are available for those opportunities, as well as a 2-week program that's based in Castleton, Vermont. So many different options for students to choose from. And it's really exciting for us to be offering these. If anybody has any additional questions, feel free to use the chat box. If not, I might just ask Melissa. Oh, I do see one. Thank you, Zoe. And so when the question is, when we began recycling plastic, it couldn't be used for a lot of stuff because it was so weak. Will that be the case for cement made from captured carbon? What do they do with all the carbon that gets captured?
I know, it's a great question. I mean, cement is one of those things that's actually really, really cheap, right? So I mean, we use way more of it than we actually need to build buildings, that would be very, very safe, because it's just cheap. So we're like, well, just add a little extra. It makes it a little bit extra strong, and that's good there. What I'll say is that when you look at actually the emissions when we're producing cement, when we're producing the stuff that is, building our buildings and our roads, a lot of the emissions come actually from the rocks when we're creating it, which is interesting, which goes back to carbon capture. Like, you've got to capture that there. But then at the end of its life, it's a great comparison with plastic. It's like, what do we do with it? The reality is we tear it down and we throw it in a landfill, and it sits there for a long, long, long time. But, it just takes up space and is wasted. So the questions are like, how can we use less of it to create the thing we want? How do we make it stronger? It turns out that we can actually put more emissions into it and it becomes stronger, so we need less of it to build the thing that we want, which is really interesting and fascinating to look at. And that's something that scientists have been working on for a while. Um, but it's one of those we really have to think about with everything that we use. Where does it go after we're done with it? So if when we tear down a house or pull up a road, like where does all that go? And it goes into landfills and it sits there. So one thing I'll say just to confirm, like with, other products, if they get contaminated and aren't strong enough to be used in different things, we don't have a good kind of recycling mechanism to like reuse cement. It it just is done after that one time through. The other thing I'll say is actually on the podcast coming out tomorrow is an entire episode on concrete and cement. If you want to know the difference, first off, between the two, we're going to explain that. And then talk about how we use it and how we get that all the way to net zero, because it's a tough one. But it's one of those that actually in the US and in Western Europe and in Iceland, they think they've cracked it. They think they've got some good paths forward. So tune in, it's free. You can check it out. And we're going to do steel in a couple weeks, so that'll be fun too, and chemicals, and which involves plastics, etc.
Awesome. I've just reshared the chat or reshared the link in the chat to the Big Switch podcast. So definitely encourage everyone to join in on that as well. So I don't see any further questions. So Melissa, is there anything else you would like to add before we wrap up here?
No, it's just one thing I'd highlight from what you said, Cassie, is that all of these topics really connect. So it goes back to like carbon capture is one of those sets of technologies. And it's not just tech that we build with metal, but it's also trees, which Iceland is fascinating for studying that. And I know we're going to go to one of the, the regrown forests that they're trying to build back because they cleared out all the trees in the country and they're building it back. And so what does that look like? And that's part of the carbon cycle. But when you think about storytelling and communicating, that's a key part in actually driving change. When you think about finance and how you move money, all these things cost money. So how do we move money to these different technologies that can help us mitigate climate change and solve this climate problem that's facing us and is really a defining challenge of all of our generations, all of us who are here on this is the defining challenge. So how do you think through that? So just encourage you to check out all the different programs and see which one speaks to you, because if you're interested in kind of just learning more about this or kind of figuring out what can I do, like all these different programs show you different ways that you can be involved, whether it's slightly more tech or more nature based or more finance based or storytelling and communication. I just think it's a really important thing to keep an eye on and to think through, because we all bring value to this conversation with our different skills and our different passions.
Fantastic. That's a great point to end on. And I will just add that there are the themes for our traveling programs, but our campus-based program in Castleton, Vermont is really meant to introduce students. If you're interested in the topic, but you feel like you want to get a little more exposure to the different sides of climate change, what you might want to consider, that is kind of an overview where we cover all topics, but we don't dive too deeply into them as these trips will on certain themes. But again, I think it's really important to think about what your interests are. I am here to answer any questions. So are my colleagues at Putney Student Travel, who've been running these fantastic programs for many years. So if you have questions about anything about which program might be a good fit for you, applications, scholarships, feel free to reach out to me. You all have my email address. And if you think of any additional questions for Melissa that you didn't get a chance to ask today, feel free to also share those as well, and we'll make sure that we get those answered as well. Thank you so much, Melissa, for your time and for walking us through. I love the soccer analogy and it makes total sense. And thank you to our viewers for joining in. And hopefully we'll see you in Iceland this summer.